asked, one of my subscribers. This video is on the LED bulb. They want to know, well, I said in the last video that I might figure out what voltage is on the output of that circuit board. So that's what I've got done here. I've actually got the board hooked up to my Omite VT8-FC variac, and the output is going directly to this meter. So we're going to figure out, so I'm going to turn the light on here, if it made any difference, what kind of output is on the output of this board. So I got my safety glasses on just in case something decides to go kaboom, but let's see what happens here. Let's crank her up. It's 10 volts AC, which is 10 volts DC. You notice I got the meter on HV, high voltage, so she's set to 1000 volts. The electrolytic capacitor is good for 200 volts, so you know, I really don't want to go anywhere near that, so I'll be keeping the voltage even though if it might want to go higher, I'm not going anywhere handy to that. So let's go to 20 volts. It's 20 volts AC, which is 23 volts DC. Let's go 30 volts AC, which is 37 volts DC. Nothing seems to be erupting or smoking yet. I mean, the input of this thing is meant for 120 volts AC, so I can't see anything happening, but who knows? That's 40 volts input. You got 51 volts DC output. So yeah, could almost use this for a tube radio and a plate for a receiver. This board. Nice. Alright, let's move over to 50 volts AC, which is 64 volts DC. That's at 50 volts right now. Nothing is smoking, shorting, making any noises. So I'm thinking we're still good. Let's go to 60 volts AC. That's 60 volts AC, which is 76 volts DC. So we're still within range of electrolytics. Again, I'm not going over 200 volts. I'm not going any, actually 125 volts DC is as much as I'm going to go on this board, just in case. Let's go to 70 volts AC. That's 70 volts AC, and we've got 90 volts DC. So that's 70 volts AC, giving me 90 volts DC. Okay, we're still good. Let's bring her up to 80 volts. That's 80 volts. Let's bring me up to 105 volts. So we're at the halfway point of what the electrolytics are good for, which is 200 volts. Alright, let's go to 90 volts. Slowly. Slowly to 90. At 90 volts, and we're at 120 volts DC. 120 volts DC. See, she's still good. Not smoking. So we're at 100. it sit there for a minute. See what it does. Okay, let's bring her up to 100 volts slowly, because I'm not going near to 200 volts. There's 125. Backing away just in case. That's 100 volts AC on the input and giving me 130 volts on the output. So boy, there's a fair bit of voltage on those LEDs on that board. Fair bit indeed. Now let's go to 110 very slowly. 150, that's as much as I'm maxing out on. Even then I think it's too much. Alright, that's 110 volts. That's 145 volts DC on the output. So, I'm going to drop her back now. I just don't trust it. So there you have it. Turn it off and unplug. The variac is unplugged. This is the test jig I had. 2 terminal strips, AC cord, which went directly over to my variac, and of course leads straight to it. So yes, for little projects like tube stuff, tube receivers, that little board may just work out very well indeed. Anyway, hope that answered your question. With full voltage, 120 volts, 110 volts in, you're getting about 140, 150 volts DC output on that board. Anyways, all the best, and I'll definitely be keeping that board. I see some tube projects in our futures. Anyways, all the best, folks. In 73. Okay, now we're going to try this with the LED board hooked up. Variac set to 0. Variac is now on and set to 0 volts. We're going to increase this a little bit and see what happens. Volts AC gives you 20 volts DC, 30 volts AC, 35 DC, that's 40 volts AC, 50 volts DC, 50 volts AC, 60 volts DC, and the board is turned on. And now she's flickering a bit. After 60 volts she starts to flicker. Put the little thing ahead of me here, in front of it. I guess this is 60 hertz signal. But she got a pretty good pulsating going on there. Although she is on. So 50 volts. 50 volts AC turns the board on. Turns the LEDs on. and about 51, 52 volts makes her flicker. Let's get a little bit brighter. And at about 55 volts, which is 65 volts DC, the bulb is fully lit. Board is fully lit. It's 60 volts AC. The board is now lit. Look at quite bright. So there's the Variac. She's at about 60 volts. AC 66 volts DC is pretty much what the board or what the LEDs need to turn on when they're running at 8 LEDs. Normally there's 9. I got one jumpered. Bring her back to 50 volts. It's just lightly dimmed. Anything over that, and she flickers. So about 55 volts is what turns on the bulb to full brilliance, pretty much. So 60 volts AC is pretty much all this board needs to run these lights, LEDs. Let's just crank her to 70 just to see if it makes any difference. As you can see, voltage is not really changing. A little bit. So that's 70 volts AC, which now giving the LED 70 volts DC. Quite bright indeed. Let's do all the lens from the bulb. How bright that is. Anyways, turn her down, reduce the voltage. That's 50 volts AC. I'm assuming that's the capacitor's charging, discharging really quick. So that's 50. .45 volts, you can just barely see the LEDs on. At 50 volts, you can see them quite well. And at 55 to 60 volts, she's quite bright. Anyway, I hope this little experiment answered a few questions there, folks. Anyways, that's it. Oh my lord. I got her on a piece of board and she's well insulated. Nothing was going to erupt. Hopefully. Anyways, thanks for watching.